Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 213 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, the host of the Observer's Notebook and also the coordinator of the training program within the ALPO. Thank you for downloading and listening. The Association of Lunar and Planetary Observers collects and analyzes observations of various solar system bodies and associated phenomenon, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners, to keep it alive. If you enjoy what you hear in the podcast, you can donate to it via Patreon. You can start off by giving as little as $1 a month. If you feel more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can find out more by going to www.patreon.com/observersnotebook. And if you'd like to join the ALPO, membership begins at only $22 a year. You can find out more at www.alpo-astronomy.org. And you can also find us on Facebook. Just search for ALPO Astronomy. And this here podcast also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear in the podcast, please subscribe. That way you'll never miss another episode. And now, enjoy this episode of the Observer's Notebook. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And today we're talking the planet Mercury, and that means we're talking the Mercury Section Coordinator, Frank Melillo. Welcome back to the podcast, Frank.
Yeah, thank you, Tim. It's a pleasure to be here. And I know I did a podcast talk a while ago, but it's the most sort of update information about the session.
Yeah. So before we get started, why don't you just give everybody a little brief history of the Mercury section and what type of information?
Yes, okay. I've been a Mercury coordinator for 24 years, and I've been active with the session every year since. And I'm very happy that it's getting a lot of attention lately, because before I took this position, back in the 1980s and 90s, there was a very few activity in the Mercury session. The coordinator was like in and out. There was no activity there, just a very few very few members observing Mercury. But then toward the late 1990s, and then I became involved with observing Mercury, and I practically the only member observing Mercury at that time. So I guess in 2001, they chose me to be a coordinator. And I've been in that position ever since. And that session was almost to be dropped because there was no activity. And once I became a coordinator, then I sprung everything up, and I got a lot of members. I contacted a lot of members. They became, almost a regular distributor for Mercury. And so I've been doing that ever since. And so that's good. I contact professional astronomers, Mercury experts, and we work together how to get the best observation as possible. Look certain things on the surface. Then we have a messenger spacecraft orbiting around Mercury between 2011, 2014, and 15, and that helped out to to make it out the details of what we saw compared to the messenger imaging, so we can able to confirm what we saw and what we imaged. So that's probably one of the most active situations that I did with the Mercury session, and I continue to do that.
Yeah, you're your apparition reports in the journal are really good. And also, I know we get a lot of positive feedback from your presentations at our annual conference every year too.
Oh, yes. Yeah. I have 2 more coming up and this conference coming up.
Great.
Yeah.
Great.
Yeah.
Okay. That's July 25th and 26th. So
Correct. Yes.
we have a podcast out there right now that people are interested in participating or joining us. You can get all the information there. All right.
Right. Good.
So if I want to observe Mercury, what kind of equipment would you suggest I get?
Okay. Well, you don't need a monster telescope.
Mm-hmm.
Okay. If you have a mid-size aperture, like maybe like 8, 10, or 12-inch, that pretty much just right. Don't forget, when we observe Mercury, we also magnify the turbulence. There's always the turbulence involved when you observe Mercury, whether you're looking through the white light or even the daylight. So what happened was, despite of the smaller disk, using the large telescope like a 14-inch, 16-inch, it won't show much because you magnify the turbulence.
And you're saying we magnify the turbulence because Mercury never gets high in the sky.
Visibility, naked eye, it never get high in the sky. But however, most of the time, we have members observe Mercury with like 10 to 12 to 14 inch. All right. So if you observe in the morning sky and you follow it up into the daytime, you still have very little turbulence, but it's better than the average. Now, most of the time, the average seeing condition, a 10-inch telescope will be just right because the 10-inch telescope, the resolution is half arc seconds. Now, most of the time, with average seeing conditions, you cannot resolve any detail beyond half arc seconds.
Okay.
Now, if you use the 14-inch or 16-inch, which has better resolution, but you weren't able to see the detail like the 10-inch does. Now, the 10-inch and the larger telescope, you see the same amount of details. Now, with the larger telescope, of course, you have a bigger image, but it won't be clearer. It won't resolve any details. So, of course, the larger telescope, it's very hard to, move around. The polability is not that great where Mercury is visible because you have to move around because Mercury is always low in the sky. You got trees in the way, building or house in the way. And usually when it's visible, it's, you're never in the right spot. The large telescope is hard to move around. And you don't want a chance to get too close to the sun if you observe it in daylight.
Right. Now you mentioned that it's largest. It's about a half arc second.
Well, the 10-inch telescope, yes.
Okay.
That's just about right.
Just to give a point of reference for our listeners, Jupiter on the average is about 30 arc seconds. So that's how much smaller the planet Mercury will be in your eyepiece.
Most of the time Mercury is visible through the eyepiece. It's about between 6, 7, 8, 9 arc seconds diameter. Okay. So that's quite small.
Yes.
So if you have a mid-sized telescope, that's just perfect.
Okay.
For the average seeing condition.
Okay.
Yeah.
All right. So within the Mercury section, do you have different observing programs that observers can do?
Yes. We have, most of the time we have, whatever the members can observe Mercury. I mean, they are programs that they have like a sodium tail.
Okay.
Mercury have a sodium tail. There's another project that, if you have a sodium filter and if you have a telephoto lens, you don't need a high magnification, but you need, like a shorter focal length telescope, and you can see Mercury during the twilight if you have a sodium filter, which is 590 nanometers. That section where Mercury light emits sodium sodium light. So it's just blow away from the sun.
Yeah,
and
that was
form
interesting
like a
because
tail.
a couple of years ago you gave a
Yeah.
talk at the conference, and
Yes, and
you
I
ta-
have a paper on that. Yes,
right,
so
and you
that's one of the excellent projects. Now, within that project, it's it's to see whether or not when the tail was longer, when the tail it was shorter, or maybe when Mercury is closest to the sun at perihelion point to see if the tail is longer, and when it's the furthest away from the sun in aphelion point, the orbit, to see if the tail is shorter. Depends how active the sun is. If that make the tail longer or what, it appears like a comet.
right.
And so only the sodium filter will able to detect that. Now you cannot see with the naked eye. Only
Okay.
the camera can pick it up.
Okay.
So that's one of the projects. Of course, you have ray craters.
Mm-hmm.
How bright they are, and when it's visible, what craters are visible at that time, which one is the brightest, why they're so bright, and some small craters, ray craters, why they're so brighter than the larger crater. It's something like that. And also, you have different solar angle, whether you
Mm-hmm.
look at the morning sky or the evening sky, and you're looking at the same part of the surface, you're looking at two different solar angle, and you can able to determine the brightness, whether it's brighter or dimmer, if it shows any better contrast
Right.
when it's on along the terminator or in the middle of the disk. And so it depends on the solar angle. You can able to determine whether or not if a certain feature on the surface appears brighter or dimmer. So that's another project you can do. And of course, you can have a face, how quickly the face can grow from
Mm-hmm.
crescent to gibbous. It's just a matter of days, and you can show if you have an animation, if you successful enough to image Mercury so many consecutive days, you can see the face change very rapidly.
Right. Right.
And
Now you mentioned sodium filters, but what other filters, color filters, would you recommend using to see more detail on the planet Mercury?
okay, beside the sodium filter, um, the best filter to use is the red filter.
Hmm.
Whether or not it's if you have a long pass filter, or you have a Raton 25
Okay.
red filter, or you have a battered thick 10 nanometers long pass filter, I thought it's red because that will, if you observe Mercury in a very bright twilight or even the daytime, as you follow up into the daylight hours, the red filter is an ideal because it blots out the blue background, the sky background, and also it increased the contrast on the disk.
Hmm.
And also will help to stabilize any turbulence, atmospheric turbulence, able to compromise that. So that will be the best filter to use. Now, visually, the red filter can be quite dense. I
Mm-hmm.
mean, it will look like it's quite dim to the eyepiece, and it's going to be a little bit hard to see unless you have a little larger telescope, like maybe like a 12-inch,
Okay.
something like that, and you're able to collect more light. But the camera is just sensitive enough to pick up,
Okay.
all different kind of wavelength, and it brings out the detail, brings out the image much better. So.
Now you've done a lot of observing of Mercury in the daytime. I've noticed that.
Yeah, always. All
Yeah.
the images that I posted, you see on the website or whatever, is all done in daylight. Now, that's the best way to get most out of Mercury. If you want to go after the details on the surface.
Now, what's your process though for finding Do you find it in the twilight and then track it throughout the day, or
No,
what's your process? What's your
no.
process for
Uh,
finding Mercury during the day?
unfortunately, I don't have a good eastern horizon.
Okay.
Okay, I have to wait when it gets a little higher in the sky, maybe like 45, 50 degrees above the eastern horizon. All right, and from where I live, I don't have the eastern horizon. So when I put the telescope, I have a building in a house blocking off the sun, and when Mercury gets higher, it will clear the roof, and I can have like a short window to observe Mercury in the daylight hours.
Okay, so use a building to block out the sun.
Yes,
Okay.
block out the sun.
That makes sense.
So the telescope had to be in the shade.
Right.
All right, and it had to be in the morning hours. I would say like maybe about 10 o'clock local time, right before Mercury reached the central meridian. Especially in the summertime, we have a better seeing condition.
Mm-hmm.
And of course, Mercury is much higher in the sky. You talk about nearly 7 degrees above the horizon, and you have a very crisp, a clean cut image there. Of course, with reasonable elongation, you don't want to observe the sun.
Right.
Observe Mercury too close to the sun.
That's a precaution everybody needs.
Yes. I'm just about to get into it. When it's at least 15 degrees of the sun, that's safe enough to observe Mercury. And then you have a short window. If you do visually or imaging, it has to be a little quick because you don't want to wait too long, and all of a sudden you have the sunlight hit the telescope,
right.
and you're gonna have a turbulence heat wave effect.
Okay.
So like in the morning hours, like 10 o'clock local time at the bedtime, because you don't want to wait too long, and you don't want to do it in the afternoon because that when the sun is heating up the atmosphere,
right.
Then you're gonna run into problems like turbulence. You can have more cloud build up, and you have more winds. So like the mid-morning hour is the best time of the day to do that.
Okay. In the Mercury section, how many contributors do you guys currently have?
Okay, currently we have an average of 6 to 8 observers.
Okay.
Mostly, I would say about 3 or 4 observe every single year, and then the other 3 or 4, then it's like they come and go.
Okay.
During the earlier part of when I was became a coordinator, we have a lot. We have like maybe about at least 10.
Oh my!
Because most of the observers were doing sketching and drawing, and there wasn't too many imagers at that time. So as the year progresses, we start to get more images.
Okay. And
we don't have too many drawing left because it's really, the images, they did a lot of improvement with the Lucky camera,
right.
Software, filters, and a lot of people go toward the webcam images. So
yeah, I know I've only visually seen Mercury a handful of times in my life, and I saw absolutely no detail on the disc. So
yeah. So the majority of the observers are all doing the webcam imaging.
Okay, all right. So you mentioned earlier about craters, and you wanted to talk about ejecta ray craters on Mercury.
Okay, yeah, I think that the most significant things that we are doing that have been made, yes, during the earlier part of my position as a coordinator, a lot of observers seen like white spots and all, but it's never been confirmed. So, and we have a dark area, dark albedo fissure, bright albedo fissures. Now, it's never been confirmed. So, yes, then I find out that the ray crater, ejecta ray crater, is most prominent, is visible very well through the amateur's telescope. I mean, they have enough contrast. They're very bright. They're relatively younger than the older craters, and the Mercury surface is much darker. And with the crater ejecta ray craters, it's just very, very bright against the darkest part of the surface, and that's increased the contrast, and that's why it's visible. It's so much easier.
Okay.
doing the imaging.
Okay,
So
and you're comparing a lot of your observations to the messenger spacecraft.
yes.
Yeah.
Well, with the messenger spacecraft, we can able to confirm of what we see or
Okay.
what we saw on the disk, and we can compare side by side, and we're able to see, yeah, that's real. Now, sometimes you have artifacts, and especially around the limb, so we're not really sure if we can detect anything on the limb, but some are clear enough. And then you have the messenger simulator. You set it up, the measures are similar, the data you're observing, then you compare to what your observation is, and you can able to compare one another, and you can see whether or not, yeah, this is real, no, this is part of artifact. So we can able to confirm that those are real features on the surface. The ejected ray crater is the most prominent feature that we can see in the imaging.
Okay. Now, this current apparition, I think Mercury reaches its greatest distance from the sun on June 26th?
Okay. Currently, it's visible in the morning sky. It will enter its period conjunction May 30 or 31st, if I remember correctly. Then it will enter to the evening sky. So it will be visible right after sunset.
Okay.
Now it's not a very favorable position because during the latter half of June or early part of July, the ecliptic will be very, very shallow.
Okay.
After sunset, so Mercury will be very, very low. But I would say that after the inferior conjunction, in the latter part of July, it will enter the morning sky, and it was going to be the most favorable morning apparition of the year in most of August.
Okay. Our schedule for releasing this podcast is in June. It's in June. So
not only that, you have Venus on the same side of the sun with Mercury. Now, if you want to observe Mercury in the daylight, you can use Venus as a guide to find Mercury.
Okay.
And it has been proven because Venus is very easily
it's so bright.
bright, and you can able to spot it in the telescope right away. And now, if you want to set up the coordination, like the right ascension and declination, you got a position, and also you got a position for Mercury, for coordination, for right ascension and declination. Then once you find that, then from Venus you can determine how far you have to go in order to go where Mercury should be. So you look at the coordination. If you have using setting circles, if you have an equatorial mount, and you can able to determine where the Mercury should appear. Then once you move to position when the right ascension declination match with Mercury, then it's a very good chance it will be in the low power fields.
Okay. And I'm sure focusing too, if you go to Venus first.
Okay, yes.
Focusing makes it easier if you're looking at Venus.
Exactly. Make sure it's focused first. Yes, I was going to bring this up. Make sure it's focused first by looking at Venus. Now, if you don't have Venus on the same side of the sun with Mercury, and there's no moon, then then it's going to be a little problem. You're going to have a hard time to find you because you don't know where the focus is, and you have no reference to find a focus. But in Remini, you can focus the night before. If you have a telescope out, then you can focus on a star the night before you're planning to observe Mercury. Now, it will be in focus. But the next morning, just be aware that now you have a different temperature, different air mass. It might be a little out of focus.
Good point.
Yeah, you got to be aware of that. But even though the focus point, it probably just a little bit off, you still can see Mercury, but it will be like a little blur of light, and just hopefully that it'll be close enough to recognize there. But if you have a moon out, again, Venus out, perfect. You guarantee a perfect focusing. Yeah. Now, what happened to me one morning? I didn't expect to see the Mercury in one morning, and I didn't focus the telescope the night before, and there was no Venus and Moon out at that time. I used the jet contrail.
Oh.
Yes, and it was a very distant plane with the contrail, and I can focus that because that in the distance, and then once I find the trail through the eyepiece, I can able to focus, and then you have a very good chance that Mercury will be in focus also.
Okay, what about using the sun to focus on?
I haven't tried that yet.
Okay,
I haven't done that yet.
Or the solar filter throw off the focus a little bit.
I do use the 10-inch, but I don't have a solar filter for the 10-inch.
Yeah, you don't want to look at the sun with the 10-inch telescope.
Yeah.
Okay.
Yeah.
Okay. So your observations, where are they published? Are they just in the journal or?
Oh yeah. Most of the article published in the ALPO journal, and all the apparitions every year I write it out, and then I have in between the apparition report I have like a special observation by Mercury. Then that be published in the ALPO journal. There's one coming up, 2023 apparition report, and there's another one coming up about the ray craters, and also about the study of Mercury's surface near the sunrise and sunset terminator.
Okay.
So that's being edited already. So I think it will be published sometime at the end of the year.
Great.
But I know that the 2023 apparition report probably is going to be in the next issue. In the summer issue. Okay. Yeah. So I keep it up every year.
Good. Yeah. So what do you see for the future of the Mercury section?
All right, it's just continue what we're doing.
Okay.
Yeah. So hopefully, we make more improvement to especially ray craters, and see which one's the brightest one. Why the smaller ray craters look so brighter than the larger ray craters.
Okay.
Just continue what we're doing. Hopefully, we'll attract more images, more members to observe Mercury.
Yeah, the listeners out there, if you're interested in observing Mercury, please give it a shot. I mean, we could always use more observations.
We all know that Mars, Jupiter, and Saturn are so well observed, and Mercury considered a neglected planet.
Right.
And even Venus, most of the time, is being observed more than Mercury.
Right. Does that hurt your feelings a little bit?
Yeah. But the funny thing, I have to tell you, and I admit this, most of the time, there's more details to detect on Mercury than on Venus.
Really?
Yes. Because Venus have a very faint ultraviolet markings. Okay. And sometimes it's hard to see, hard to detect. Sometimes it's very bland and all. But Mercury is the detail is always visible once you have everything set up correctly.
Well, that's true. And with Venus, you're looking at clouds.
Yes.
With Mercury, you're looking at the surface of the planet.
Yes.
Right.
But even the surface, there's always something to see.
That's very true.
And also if I have any additional information, we have a space mission, Petro Colombo, on the way to Venus. That's the combination of the European Space Agency and Japan Space Agency. It's a joint mission, and now it's on the way to Mercury. And I think if everything goes well, it will be in orbit the end of next year.
Oh.
And so they have some flyby images of Mercury, and I'm going to demonstrate some of the images that are taken by the flyby compared with my images. I happen to image the same part of the surface as a Petro Colombo mission took flyby. And that compared and side by side, it's amazing. So I'm going to show that at the upcoming ALPO virtual meeting.
I look forward to that, Frank.
Yes. So that's another thing we look forward to in the near future, working with Petro Colombo space mission on Mercury. So we can able to detect more features. Hopefully, that the spacecraft probably will image any more part of the surface that the messenger miss. I'm not quite sure. And then also image a different solar angle, why this part of the surface is brighter and another part of the surface is dimmer. So it depends on the solar angle. So we can do the same thing. Whether or not to look at the morning or the evening sky, and you look at the same feature on the Terminator, see whether or not the solar angle make any difference to show the brightness.
Yeah. Okay. Well, I look forward to seeing that presentation at the conference.
Oh, yes. I look forward to it, to demonstrate what we can see on Mercury. Yes. A lot of people, don't really realize what they miss. I mean, they assume that there's nothing to see on it or too hard to see. They give up very, 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 very easily. So that's why
the technology with imaging is gaining every year. I mean, what we're able to see and the software to improve the images and everything. It's where we were. I was talking to somebody the other day about film.
The film is.
And now we're at a point where what's film, right?
Yeah. Well, I was using film first.
Oh, we all were
in the 90s.
We all were, yeah.
But, I mean, I was just lucky enough to detect the face. That's it.
Yeah.
Faces. Yeah. Now we see Mercury at the world more than the face.
Right.
We see Mercury at the world.
Right. Well, Frank, this has been great. I want to thank you for coming on the podcast today.
Oh, you're welcome. You're welcome, Tim, and thank you for inviting me. And hopefully, in the near future, I get more information about Mercury and what we learned since that time.
All right, we'll have you on again. All right, thanks, Frank.
Yeah. Okay. Bye-bye.
Well, that'll do it for this episode of the Observer's Notebook podcast. I again want to thank Mercury Coordinator Frank Melillo for coming on the podcast today and giving us good discussion about observing the planet Mercury. If you're interested, get out there and observe. We upload a new episode of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please rate and review us. I'd really appreciate it. You can also listen to us on Apple Radio, iHeartRadio, Soundcloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and yes, the podcast is also available on our ALPO YouTube channel. You can help support the podcast by donating to it via Patreon. You can start off by giving $35 a month, where you receive 1 year's membership to the ALPO and producer credits on the podcast. And with that, I'd like to thank the producers of this podcast, Steve Siedentop and Michael Moyer, for their generous support of the Observer's Notebook. Thank you very much, gentlemen. The link for Patreon, as well as the link for the ALPO, is in the show notes. If you'd like to get a hold of me, my email address is cometman@cometman.net. And until next time, my hope is you always have clear and steady skies. Thanks for listening.